Good day, and thank you for joining, and welcome to today's webinar, Mobile Matters, How Financial and Insurance Firms Can Optimize Mobile Experiences, brought to you by Akamai Technologies and Information Week Financial Services, and broadcast by United Business Media Limited. I'm Jim Graves, Head of Financial Services Industry Marketing at Akamai, and I'll be moderating today's event. We have just a few announcements before we begin. You can participate in the Q&A session by asking questions at any time during this webinar. Just type your question into the Ask a Question text area below the video window, and then click the Submit button. At this time, we recommend that you turn off your pop-up blockers so that you actually will enable pop-ups. The slides will advance automatically throughout the event. You may also download a copy of the slides by clicking on the Download Slide button located below the presentation window. If you are experiencing any technical problems, please visit our Tech Webcast Help Guide by clicking on the Help link below the media player. In addition, you can contact our technical support helpline, which is also located in the Webinar Help Guide. Now on to the presentation. Let me introduce today's speakers. Lorenz Jakober is the Senior Product Marketing Manager for Akamai's Web Experience Solutions. Lorenz has a wealth of experience in web and mobile application design, performance optimization, usability, and delivery. Prior to joining Akamai Technologies, he drove mobile product marketing strategy for CompuWare Gomez. In past positions, he focused on customer acquisition retention and market research at mobile application delivery platform and media companies. He's an avid spokesperson and blogger on the topic of mobile and web performance, and has recently been featured in industry publications including Mobile Commerce Daily, Information Week, and Media Post. Rob Yates is a Senior Solutions Engineer in Akamai's Security Center of Excellence. Rob has more than 10 years of experience in designing and supporting web and mobile platform architectures, and is focused on supporting financial services firms. And now let's get started with today's webinar, beginning with Lorenz.
All right. Thank you so much for the introduction. So as we all know, when we think about delivering experiences to our end users at this point, we no longer really go online, we are online, right? It's been a long time since we actually had dealt with end users that would sit in front of a desktop or even a laptop, open up Internet Explorer, visit your site over a cable connection. These days it's all about smartphones and tablets, as we well know. Particularly if we look at mobile banking adoption, it just continues to grow. That's probably not news to anybody, so we won't be spending a lot of time there. One thing I did want to highlight, however, was that when we start to look at the statistics in a little bit more detail, what is very interesting is the fact that new customer acquisition in particular really requires a mobile-first type of approach, or one would say even a mobile-first type of focus. Now when we think about what does that actually mean, so in other words, when we start to think about actually delivering web experiences to mobile devices, right, smartphones and tablets, what does that actually look like, right? Also, the first thing to think about is the fact that constrained devices and constrained networks are really the new normal. So what do we mean by that? Well, as we start to think through the proliferation of mobile devices, as we start to think through the actual merging of different device types, so you now have sort of the traditional smartphones, they keep getting bigger, right? Start crossing into phablets, start crossing into tablets, etc., etc. That proliferation only gets bigger. Now, when we actually look at those devices themselves, what we inherently already know is that they are far less powerful to the actual devices or platforms that we used to develop for in the past. So in other words, if we look at, a high-end laptop and compare it to a high-end smartphone, we can see that obviously from a CPU and a memory perspective, the smartphone is much more constrained. Now when we think about what that means from a web performance perspective or a web experience perspective, we start to think about the browsers themselves or even the native applications, depending on whether they're using a WebView type of approach or whether they're running native code. But in this example, it's actually looking at JavaScript performance. So as we know, and as we'll talk about a little bit later, our sites have become much more interactive, much richer, which usually depends on quite a bit of JavaScript. Now, one of the great ways to easily benchmark a browser's capabilities and the device that it runs on from a JavaScript perspective is something called the spiega JavaScript benchmark. And as you can see here, the benchmark runs in around 145 milliseconds or so on the laptop in Chrome, which is pretty fast, right? Now, when we run the same type of benchmark on a high-end smartphone in Safari, we can see that we're always looking at 2 seconds or so, right? So already there, that's definitely something that you need to be aware of as you think about how do I deal with delivering quality experiences to these mobile users. But the devices themselves are one part of the puzzle. The other part is obviously the networks. So for customers to actually get to your content, right, they need to cross the network to either hit, your data centers or hit your content delivery network partners, whatever it might end up being. The key is when you start to think through the networks that these devices leverage, we look at the network in really 2 specific ways. The first is we look at it from a bandwidth perspective. So that's pretty much how big your pipe is, right? But we also look at it from a latency perspective. That's really how long your pipe is. So as we can see, there's major differences from a bandwidth perspective if we look at residential broadband or residential Wi-Fi versus cellular type of networks like LTE and 3G, or even Wi-Fi networks that are being deployed in branches. The interesting thing from our perspective, though, particularly when it comes to web performance, is that the actual bandwidth is important to some degree, right? But because it's usually very bursty traffic, what we really care about is latency. In other words, if you can reduce latency from a web performance side of things, you will have a very big impact as far as improving the experience of your end users. The challenge with that obviously being is, particularly as we start to look at the cellular type of connectivity with LTE and 3G, latency is very, very high. So having to deal with that new type of network and those new type of network conditions is something that you definitely need to be aware of. Now, when we think about latency, latency is not only tied up with the different network types, it's also tied up with geo-based latency. In other words, you'll never likely really beat the speed of light, right? That's just a given at this point. So what you're actually looking at here is a reference application that's running in a data center in Northern California that's being measured by synthetic measurement nodes located around the world to try to figure out how quickly it loads. And as you can see that in Northern California, so San Jose, San Diego, and even Los Angeles, performance is pretty good, right? Not too bad. But the further away you get from the data center, the worse performance gets. So geo-based latency will likely always remain an issue. Now, we've talked a little bit about the devices. We've also talked a little bit about the networks and the challenges they pose. The other thing that we've really seen over the last few years is that our pages themselves have gotten significantly bigger and more complex. Now, that holds true both for pages that are mobile type of pages, so specifically optimized for a mobile device like an MDOT site, as well as pages that are actually delivered to tablets and things along those lines. So what you're actually looking at here is some data from the HTTP archive, which looks at the top 300,000 sites in the world and compares how they've changed over time. This is about a 18-month or so window, and you can see that the actual size of the actual pages has increased significantly, as well as the number of requests that those pages actually make over the network has also increased. Now, if we think about why that has happened, there's really a couple of key culprits for it. The first is obviously images, right? Our sites keep becoming richer, they keep becoming more engaging, and one of the ways to try to achieve that is through more vivid and rich imagery. The other side of it is obviously also trying to actually increase the functionality of the site. In other words, making it more dynamic, making it more interactive. And the way that we usually achieve that is through JavaScript. So you can also see the fact that our JavaScript size has increased significantly over the last few years. Now, if you think back to what we talked about just a few slides ago, where we talked about, okay, we have very constrained browsers and devices, right, that are much, much slower processing JavaScript, as well as very high latency, low bandwidth type of networks, right, and you kind of combine that with these bigger applications that are much more complex, you can start to see where we're going to be running into problems. The other thing that we've seen over the last few years is really this proliferation of third-party requests. So what do we mean by that? Well, what we mean by that is really anytime you're delivering a site these days to your end users, you don't necessarily own all of the content or control all of the content that's being actually delivered to your end users. In other words, it's not all coming from your own infrastructure. And the first time that content is really assembled is in the end user's browser. So in other words, whether it is, for example, ratings and reviews, whether it's advertising, whether it's beacons, whether it's chat functionality, whatever you're leveraging third-party services for, that type of trend just keeps growing. We can see in 2011, on average, once again looking at the HTTP archive data, there were around 18 or so third-party requests per page, which has grown to 25 in 2013. Right? And many sites have many, many more, as you can see here, beyond the 50th percentile and the median. Now, one of the things to note is when you think about these third parties, right, one of the areas that you need to be aware of is what happens to the end user experience when one of those third parties fail. In other words, is your application actually architected to fail gracefully and not impact the end user experience? There's ways to actually architect your application to do that. Now, one of the growing trends that we've seen with our customers, both in the financial services industry as well as all the other industries that we work with, is this growth of responsive web design. And for the most part, responsive web design sites deliver the same content no matter the device or network. In fact, we were pretty interested in this fact and did some research on close to 500 or so responsive web design sites, quite a few of which were for financial services companies. And what we found was that the vast majority delivered the same content across all different screen sizes. And that is obviously an issue when it comes to performance. Now, delivering fast quality experiences has always been difficult. Right? It's never really been easy. In fact, we can see here, based on some performance data from Compuware Gomez, by looking at the US top 50 banking homepage response times, we can see that some companies are better at this than others, right? We can see that the fastest bank, from a homepage perspective, loads in about 1.54 seconds. We can also see that the slowest comes in at about 13.6, which is quite a difference. Now, when we think about how this was measured, we know that this was a synthetic tool, right, in a desktop browser, likely run in a data center, possibly even on an end user's PC, right, but pretty high-powered hardware, possibly connected over a wired connection or even in a tier 1 type of data center. Now, when we take one of the fastest sites and we actually leverage our own Moby test and we run the same site to try to understand what that experience would be like on an iPad, we quickly see that those sites are significantly slower, right? In this case, around 9.19 seconds. So I think the first thing that I would really ask you to do is make sure that you understand the type of experience you're delivering to your mobile users through either a tool like MobiTest or another type of technology that we'll talk about a little bit later on called real user monitoring. The real gist behind this is, though, that delivering fast quality experiences has always been difficult, But now as you start to think about all the different devices that you have to deal with, all the different networks and all the different browsers, it's become even more so. Now the next question might obviously be, well, so what? Does this really matter, right? If I'm a second slower here or there, maybe nobody will notice, right? Well, the truth is it couldn't actually be further from that truth, right? So we actually did some work with Forrester Research back in 2009 where we asked what percentage of end users would expect a website to load in 2 seconds or less. And what we found was that around 50% or so at the time on PCs said, we expect a website to load in 2 seconds or less. Another company did a similar survey but for smartphones a little later, and they found that 34% actually expected websites to load in 2 seconds or less. That same company actually repeated the study in 2012 and found that close to 70% of tablet users expected websites to load in 2 seconds or less. And now as we start to think about what this actually means for us, there's a couple of key things to think about here. The first is, one thing is clear. Expectations just keep on rising, right? As with anything else, whether it's a new iPhone or a new Ferrari, right? It always has to be faster, more powerful. The same with web experience expectations, right? They keep growing. Response time expectations keep getting lower. The other thing to think about is the fact that it highlights the fact that end users don't really care about the underlying technological challenges associated with delivering quality experiences to mobile devices. And they can clearly be illustrated by the tablet example. Now the question then becomes is, what happens if we don't meet those expectations? What happens if we don't necessarily deliver a quality web experience? Well, surveys have told us that if mobile users are dissatisfied with website performance, close to 50% of them, in fact, for tablet users, will be unlikely to visit the site again. Surveys have also told us that 33% of tablet and 26% of smartphone users are also less likely to purchase from that company across all channels. Now, what people say in surveys and what they actually do are not always the same thing. So it's been great that we have seen more and more industry data come to ground that really highlights this. This is actually some real user monitoring data from CompuWare Gomez, where they tried to correlate page load time to abandonment rate. And then they looked at that data for across 280 or so websites, and they sliced and diced it by iPhone and iPad users. And what they found was pretty clear, right, as you can see in those graphs. The slower the pages got, the higher the abandonment gets. Now, one of the things to note here, particularly from a financial services perspective, is this doesn't necessarily mean that your end users will never ever will essentially switch a bank or do anything along those lines. What it does mean is that they will likely use a more expensive channel, right? So instead of using the mobile application that you've A, spent time developing and promoting, right, or B, the online banking that you make available, if it is slow, they will likely use it less, right? They'll be abandoning early. So the next question really becomes is, well, what can I do about this, right? How can I improve web experiences across all these different situations? So what you're actually looking at here is what's called a waterfall chart. And it might look a little crazy, but it's really literally what it takes for a web page to load in an end user's browser. Each one of the lines represents an object that needs to get loaded for the web page to render. You can break this down into kind of two distinct parts. Here's what we call the backend, which is what happens when an end user actually types the address into the URL bar. That request goes to your server. Your server does all the processing between the web server, the app server, and the database, and that response back to the end user. The next component is really the front end. And the front end is pretty much everything else. It's all the JavaScript, it's the CSS, it's the images, it's everything else that's required to actually build that page and render that page in the browser. And what's become pretty apparent early on was that the majority of end user response time is spent on the front end. Now, that's not to say that you shouldn't optimize the back end. The back end is definitely important. But if you really want to impact your end users' experiences, the front end is where you should really start. So now we really get into the questions of, well, how can Akamai help with this? So at Akamai, we really focus on a few key areas. We focus on scale, we focus on performance, and we focus on intelligence. So we're a distributed cloud platform with over 150,000 servers in 92 countries within over 1,450 networks. On average, we deliver between 15 to 30% of all daily web traffic, and we pride ourselves on the fact that we are a single network hop from 90% of internet users. This obviously makes it relatively easy for us to leverage this platform to make sure that a server is as close to your end users as possible, as well as making sure that a server is as close to your origin as possible. So when we think about scale, we really think about how do we help you maximize origin efficiency. We think about how do we make sure that your applications are scalable and always available and always online. When it comes to performance, we really focus on kind of 5 key areas. We focus on how do we deliver faster responses. We focus on anticipating actual requests that end users might make through prefetching. We also then look at the applications themselves. We focus on reducing requests, minimizing the payload, and expediting rendering. And we'll talk a little bit about each of these in a second. And then the last thing that we try to help our customers with is really all about intelligence. And that's focused on 2 key areas. The first is insight. In other words, how do we help you understand your actual end users? And then also logic. Logic is all about empowering both our edge as well as your origin with information. So if we think about how do we actually optimize web experiences across all situations, the first thing that is just as relevant in a mobile world as it is in a desktop world is to get content as close to your end users as possible. We saw the geographic as well as the network latency early on. Making sure that you can remove as much of that latency as possible is paramount and will remain to be so. Now, because sites have become pretty dynamic, you can't necessarily cache everything at the edge, close to end users. So you also need to make sure that you have a way to accelerate requests back to your data center or your cloud provider, depending on your architecture, to make sure that those requests actually happen as quickly as possible. And then the last area is really to actually start to look at those applications themselves. So how do we look at those applications? How do we optimize them by, for example, reducing the number of requests? Because as we say in the web performance community, the fastest request is really the one you don't have to make. So if you can actually look at your application and you can optimize it by, for example, concatenating scripts or CSS files, or are not necessarily even loading content that's not required in the actual viewport, things along those lines, that will help you from a performance perspective. If you do have to make a request, the next step is really thinking about how do I actually reduce the number of bytes that are delivered. In other words, how do I leverage compression? How do I maybe even deliver browser-specific image formats that are much more compressed than the standard image formats that might be available for us? And then the last piece is really all about how do I actually improve the perceived performance of my web applications. So in other words, how do I actually accelerate the rendering of my applications so that they seem like they're loading faster to my end users? And this is really achieved by not necessarily loading content that is invisible to even some tricks that you can do from a browser prefetching type of perspective. But as we know, being fast is definitely very important, right? But it only really matters if you're always available under all traffic conditions, right? If you're only fast some of the time and then you slow down under traffic conditions when it matters most, or even worse, you're not necessarily available, that can be an issue. Now, we have seen with the advent of more sophisticated monitoring systems like real user monitoring, that actually looking at performance and correlating it to traffic has become much, much easier. So this is actually a chart from one of our customers, and you can see the page load time in red and the actual traffic in blue. And this is pretty much what most of your teams are working towards. The fact that independent of the actual traffic for your application, whether it's legitimate or non-legitimate traffic, the actual experience that you're delivering to your end users stays the same. So I hinted at that earlier. One of the things that we now need to obviously start thinking about even more, particularly also when it comes to mobile, is the fact that those unplanned spikes in traffic might not always be legitimate end users. They could also be attack traffic. In fact, we worked with a customer for a mobile check deposit application, and we suddenly saw 120,000 requests over 4 hours from the same IP. Obviously, that's not viable. So we detected that suspicious behavior and automatically denied the access requests. Now, as we think about delivering these quality experiences, the next thing to really think about is, well, you can't really optimize what you can't measure. So we have various ways of doing that. We can do this through, let's say, more traditional approaches, like synthetic monitoring, which is great for operational type of monitoring. In other words, how do I synthetically play back a transaction in a clean room environment, usually in a data center, over the internet backbone, for a limited number of pages, locations, and browsers to understand whether my applications are up, or also get a sense of how those applications might be faring in the wild. Now, because they are run in data centers that are usually on the internet backbone, because it's synthetic robots that are running on servers that are pretty high powered, they don't necessarily really reflect the reality of your customers. Because in the end, your customers don't live in your data center, right? So one of the technologies that has really helped with understanding the experience that your customers actually have on your site is something called real user monitoring. And real user monitoring took a leaf out of the web analytics book, where it actually leverages JavaScript to harvest browser performance data straight from your end users. Now, this is real-world data. It really is a single source of truth. It also, the great thing about it is it covers all of the wireless carriers or local ISPs that your customers use. It covers all of your end users' locations, all of the pages that they visited that were instrumented, as well as all of the different browsers and devices that they use. Now, being able to see this type of data really allows you to understand end users' performance. And you can look at this data in this example with the Akamai Real User Monitoring solution. You can look at this type of data and you can slice and dice it by a different OS or browser or even network name or network type. You can also look at it across different countries or versions or even some very specific Akamai type of capabilities, like is the end user leveraging Speedy or some of our advanced front-end optimization capabilities. It also allows you to really understand whether your most important users are having a good experience. This is actually an example where we can see that one of our customers found out pretty clearly that US iPhone users were having a much better experience than US Android users. Now the question becomes is, well, this is great, right? But so what? What am I going to do with this information? Well, the great thing about RUM is, because it is based on your actual customers, you can quickly understand whether there's a lot of your customers that are having this issue or very few of them. In this case, it becomes pretty clear that this particular customer actually has almost twice as much Android traffic as they do iPhone traffic. Yet their site is significantly slower for Android users than iPhone users. So this information then allowed that customer to go back to the development team and say, okay, let's start trying to figure out the synthetic testing and object level detail, what's really going on here, and how can we improve that experience which you can then once again see in the real user monitoring results, and which becomes a very virtuous cycle, right? You pretty much understand what's happening to your end users, you optimize, you see the improvement, and so on and so forth. So really to summarize on how to deliver fast quality mobile experiences, there's really a few key takeaways. The first one is, don't make your mobile users wait. The second one is, adopt your customer's perspective. In other words, understand what they're experiencing and focus on your customer situations. Understand what networks they're on, what browser, what location, what device, etc. Then you need to think about how do you optimize performance across these different networks, devices, as well as different locations. The first step is get content closer to end users. The second is make sure that you can accelerate requests back to your data center or cloud provider. And then lastly, start to actually look at your applications. Make sure that you optimize them to reduce requests, to reduce bytes, and to accelerate rendering. And then lastly, once you've achieved all of that, make sure that they are always available and scalable under all traffic conditions. So that's really all I had to cover today from my perspective. I would just ask you to remember to put your questions into the actual media player box so we can answer them and follow up on them later on in the session. With that being said, I will actually now pass it over to Rob to talk about how Akamai helped one of our customers in particular. Rob?
Thanks, Lorenz. So when we first engaged with this particular customer, there was a few things they told us. Number one is they were really concerned about performance. When you look at it, they had a fixed number of data centers. They had 2 data centers in the U.S., but their users were located all around the United States. This ultimately resulted in inconsistent performance depending on where end users happened to be loading the page from. They also had a large number of users coming across from both desktop and mobile experiences. So ultimately they ended up in a situation where they're dealing with different types of devices, different types of locations, and across all different sorts of connections. They spent a lot of time working on optimizations, trying to accelerate the app with code changes, with different techniques such as responsive design, working with just-in-time loading, and so forth. But eventually they reached a point where they said that we needed to try and look at other situations and other ways to accelerate performance. The primary factor for driving that experience was wanting to improve their Gomez benchmark rankings. In fact, the particular customer contact actually described the Gomez rankings as being an albatross around his neck. The same time, the customer was worried about delivering these assets, but they also had to deal with other groups within the organization, such as making sure they didn't sacrifice security, and they also had to make sure they did this in a way that would be accepted by groups such as RISC, such as InfoSec, and with their other security teams. So ultimately, what we ended up implementing was bringing the customer on board the Akamai platform. It was broken out into about a 4-phase integration. Phase 1 was just on doing the initial onboard and doing the basic route optimizations. The process took about 30 days. Most of that time, in fact, was spent on QA time. The base configuration was actually available to the customer in about a week. And ultimately, when this integration was done, there was no hardware changes, no software changes, and no code changes that had to be done to do the integration. And as you can see from the slide, what we'd set up to validate that acceleration was taking place was a monitoring test that was placed on the site. So we set up a test that would measure the performance of the site every 5 minutes from different locations around the U.S. and around the world. And we had that test running for several days before we went live and then several days after we went live. From the slides, you can actually see the drop in response time going, cutting that load time in more than half. That also goes to show that it's happening not just in one particular segment, such as if users in Washington, D.C. were getting a decent experience, but also across different geographies just across the board. So let's dive a little bit further into these geos and what the differences are. The overall performance increase for this globally was about 157%. Now, if we dive into this further, we can see that individual locations such as Atlanta and Boston and Chicago saw very similar results. If you look at the results, New York ended up seeing a much bigger performance gain, whereas locations such as Atlanta, which was where they had one of their primary data centers, didn't have nearly as much of an increase, but still something that was very measurable. The graph that you're seeing, or the chart that you're seeing on the screen now, actually goes to show just some of that same data in a statistical format, whereas performance rounding out to being anywhere between a 73% increase to over a 200% increase, depending on where geographically the test was being distributed from. The other area that was unique in terms of performance for this particular application wasn't just the overall end-user experience. One of the factors that the customer ended up experiencing as a result of more of the requests coming from the Akamai network was origin offload. So in this particular case, the customer was experiencing nearly a 90% request offload. And what this means is, because Akamai is essentially a large reverse proxy, we sit between you and your end users, it means less requests are coming back to your data center. Now, why is that important? Is that, number one, users got a faster experience. They got that object faster than if they would have had to go back directly. But a secondary result of that is that there's also a fewer number of requests coming back to you, meaning you need potentially fewer physical servers, you need less bandwidth to service those accounts, you need less software licenses. The more you can increase your offload, the less you need physically in your data centers to handle the requests that are coming in to support the request. The other part that was important for the customers too was saying, how do we reduce the attack surface? And in reality, when you look at the requests coming in, ultimately it's broken out into a few different phases. Just number one, being on the Akamai platform. By having Akamai sit as that proxy between you and the end user means that all requests for non-valid types of requests, TCP floods, SYN floods, UDP floods, and so forth, are automatically blocked. If somebody tries to just send a lot of noise at your site, it hits the Akamai platform and falls off. The next part, that if we look at that attack surface, it's reduced by saying, okay, so the only way that you're going to attack me now is with potentially legitimate requests. Okay, what happens if I send a whole bunch of legitimate requests at you? The more content that Akamai can serve from cache, the more that we can potentially offload in terms of the attack surface. So more data that we're able to serve from cache allows us to go back and ultimately ensure that users aren't potentially able to overwhelm the origin and take the site offline. And then finally, the number of requests that come back, and what we're not going to spend a lot of time talking about, is Akamai actually also has technology that's available to help filter attacks that might be targeted towards those dynamic requests that have to go back to the origin for different scenarios. So ultimately, by utilizing the Akamai platform, in addition to getting the offload and increase in performance of a site, customers were able to reduce the overall experience and attack surface that their site could potentially be attacked with. So in summary, this particular top 10 U.S. bank saw an improvement of almost 157% in homepage load times. Their average load time for their homepage was brought from about 2.4 seconds without Akamai to just under a second with Akamai, and saw almost a 90% decrease in the amount of traffic that was coming back to their origin infrastructure, ultimately allowing them to focus more on what their key areas were and allowing them to also focus on improving the end user experience, whether that be for desktop users, mobile users, or whatever type of experience they were trying to deliver for their end user. Jim, I'm going to go ahead and toss it back to you, as I think there was a few things you needed to wrap up with.
Thank you very much, Lorenz and Rob, for sharing your insights. Now, after 3 quick background slides on Akamai, we will start the question and answer session. And a reminder that you can submit questions in the box below the media player. Akamai is the world's leading cloud-based platform for helping financial firms to provide secure, high-performing user experiences on any device anywhere. Thousands of customers use the internet for their sites, their critical applications, and their media. Take advantage of Akamai services. In the age of the hyper-connected user, financial firms use the global Akamai Intelligent Platform to make the internet faster, more reliable, and more secure for their web and mobile businesses. To handle even the largest demand spikes and to handle today's massively distributed and massively scaled cyber attacks, it's essential to use an architecture which is also massively distributed and massively scaled. With more than 150,000 servers in more than 2,000 locations in more than 80 countries and with direct connections to more than 1,100 key networks, Akamai provides unmatched scale. This network delivers highly distributed protect and perform services and always-on security at the edge of the internet and far from our customers' data centers. With more than 20 terabits per second of capacity, financial firms depend on Akamai to help ensure the availability of their websites and applications. The leading financial services companies, including the top banks, asset managers, insurance, online brokers, stock exchanges, Canadian banks, credit card brands all depend on Akamai. In fact, these firms conduct more than $1 trillion worth of financial transactions on our platform every year. Before we begin today's Q&A, please fill out the feedback form that was opened on your computer. To complete the form, please press the Submit Answer button at the bottom of the page. Your participation in this survey allows us to serve you much better. And now on to the question and answer portion of our event. Once again, as a reminder, to participate in the Q&A, just type your question into the text box located below the media player, then click the Submit Question button. We do already have some questions in from the audience. Thanks for those of you who have participated. Let's see, the first question I have here is for Lorenz. The question is, isn't mobile just slow because cellular networks are slow?
Yeah, that's a good one. One of the things to think about is definitely there are challenges associated with delivering quality experiences over cellular networks, right? We saw that they are generally much lower bandwidth and higher latency than obviously what we're used to with wired networks. Now, there's been some advances with true 4G with LTE and things along those lines, particularly when it comes to latency. That being said, one of the things to think about is, yes, to some degree, mobile is slower because of cellular networks. However, when you look at your competitors, right, or even other companies that are delivering mobile experiences, the key thing really is to try to figure out where do we fit in with their overall experience that they're delivering. So in other words, don't look at your own performance numbers in a vacuum, but try to compare them to others. Because that also makes something usually pretty apparent pretty quickly, is that there are companies out there, both in the financial services industry as well as other industries, that are really, really good about delivering quality experiences even over cellular networks. So you can't necessarily just keep blaming the cellular networks for poor performance.
Thanks, Lorenz. Here's another question. I'm going to ask Rob to answer this one. Where does Akamai have data centers in the U.S.?
Sure, that's a great question. Akamai itself doesn't actually own its own data centers. We actually use locations around the U.S. and around the world. In fact, there's over 2,000 locations basically in every single major city with 1,100 networks, 750 cities. So ultimately, Akamai's end goal is to be within one hop of the majority of the Internet's users. So if you actually want to see where Akamai's physical servers are, we actually have an iOS and Android device app available on the iOS store and the Android store. Download that. You can actually see specific locations, but basically every single major location in terms of a U.S. city, we have points of presence in.
Thanks very much. Next question is for Lorenz. I'm dealing with a group of marketing people who keep wanting to add more content and functionality to our apps. How do I make sure that doesn't impact performance?
Yeah, that's another common one. Being a marketer myself, I can kind of understand where they're coming from. You always do want to keep improving the richness of the site, right? But often it's tough for teams that aren't necessarily focused on performance or development to really understand the impact that they might be having on the web experience overall. So a couple of key ways that we've seen our customers deal with that. The first one is making them aware of what the consequences are likely going to be of wanting to implement either additional functionality and or additional content. That's sort of one area of it, right? Usually once there's a certain understanding, that allows there to be a conversation about, well, what's kind of the trade-off? Some of our more advanced customers, what we've actually seen is that they try to actually start out almost with a performance budget. So in other words, they will say, okay, well, we do not want to degrade our performance by X amount, right? And any type of functionality that we want to add to the site needs to fall within those certain parameters and constraints, because otherwise we believe that the actual implementation of those new capabilities or different content or whatever it ends up being will be detrimental from a performance and experience perspective, which in the end will impact our business, which is counter to what the marketing folks were likely to achieve in the first place. So that's usually the way that that discussion goes.
All right, thanks, Lorenz. The next question's for you too, Lorenz. How can we stay on top of all the different new devices, versions of browsers, and all the other changes in how users access our mobile services?
Yeah, so I think the first key to that is, getting a handle on what your end user is actually using, whether you do that through web analytics or whether you do that through real user monitoring. Some sort of type of solution that allows you to do that would be very important there. The second thing is, as you start to think about how you actually engage with mobile users, we've seen companies take multiple different approaches, right? Obviously, there's the native application side, where then obviously you have to deal with Android fragmentation and all that kind of good stuff, which is an entirely different talk track. But if we just focus on web for a second, there's really two sort of approaches that we see. One is much more of a sort of server-side type of approach with m.and t.dot sites, which really depends on a server-side client database, right? So in other words, a request either hits your partner, like Akamai, for example, and then we can tell what type of device it is and either send that info back to your origin or actually make a decision right on the Akamai edge whether you want to redirect to a different site or deliver different content. There's sort of that approach. The key there of keeping up with the latest devices is making sure that your device database is always up to date. Obviously, I can really only speak to Akamai's capabilities there, but one of the benefits of seeing between 15 and 30% of web traffic is that we have a very good understanding of what type of devices are hitting our customer sites and seeing the volume of traffic that is coming from those devices, which obviously also means that our device databases get updated very, very frequently based on that level of intelligence that we see based on the traffic. The second piece is, as we start to see, I would say, customers evolve their mobile strategies, there has been a lot of focus on responsive web design. And obviously, because responsive web design is all about delivering the same content to the device and then letting essentially the client adapt it to the different screen size, the whole idea that you need to continuously keep up with this deluge of different devices, with redirection logic and all of that, is pretty much taken out of the equation. So from that perspective, it really depends on your approach. That being said, responsive web design is a great way to deal with it. There are definitely challenges from a performance perspective, but they can also be pretty easily overcome if you understand what the challenges are, and then also if you work either internally or with a partner to help you overcome them.
Okay, thanks, Lorenz. Next question is for Rob, and it is, do you accelerate dynamic content as opposed to static content, like an insurance quote or a mortgage rate or a similar request for a financial firm?
And that's a great question, and the answer there is absolutely. So there's a number of different techniques that Akamai can use to accelerate content that can't necessarily be cached for whatever reason. Akamai has route acceleration protocols, TCP optimizations that can be applied, as well as if you have a page that has personalized information, there's typically in that base page itself a mix of other static objects that are also associated with it. So if we're talking about that insurance quote, for example, that's being generated, we may not be able to cache that base page, but we can make sure that it takes the best path to get back to the origin to request it. And we can also make sure those other associated objects that are being requested, the logo, images, JavaScript, style sheets, and so forth that are being called to render that quote page actually is served from cache potentially there.
All right, thank you very much. The next question is from someone who says they work for a health insurer and who has launched a mobile website about a year ago and is now seeing it crash much more frequently due to the amount of rapid increases in traffic there. Lorenz, what advice do you have for this person and how to deal with that kind of an issue of rapid increases in traffic?
Yeah, so I think the key thing there is the bottom line is you want to have scalable infrastructure, right? Now, how you get to scalable infrastructure is to some degree entirely up to you, right? You can try to invest in that from your own perspective, but for the most part, that's likely not viable, right? We've seen that a large part, in fact, the majority of our customers obviously have decided to go against that. You can also work with a provider like Akamai, obviously, to help you with that, right? To essentially have us handle a lot of that traffic for you. As Rob showed earlier with the offload numbers, that's obviously one key way to deal with traffic spikes, both planned and unplanned. One of the things that we've seen where kind of capacity planning and scalability has become a lot more challenging is because you are no longer just planning for, I would say, real traffic, which is not necessarily the right word there, but where you're dealing with legitimate traffic, so to speak. So now trying to actually plan for traffic spikes that are actually or could possibly be DDoS attacks has become virtually impossible to essentially absorb those from an origin infrastructure perspective, mainly because the NTP reflection attacks and things along those lines have just got to such a scale that only cloud platforms like Akamai can really help you from that perspective. So I would say probably the best approach is to work with a vendor like Akamai to help you with your scalability issues.
Okay, thank you, Lorenz. The next question is for Rob, and it is, how much work does one of your customers have to do to get started with a performance acceleration, and how long does it take?
So when you're dealing with performance, it's not just a set and forget type of scenario. Now, when a customer comes on board the Akamai platform, during the initial integration, that process is typically about 30 days. That process looks something from the time of first engagement from the date of contract signing to the day the initial configuration is live, about 30 days. An initial kickoff call is held with the customer where we help understand what the requirements are, more information about the site itself, what can be cached or what can't be, what techniques are we going to use to apply for acceleration, and from there we create an initial configuration. That process is typically pretty quick. We'll have that initial configuration turned around in a week. The bigger part of where a customer typically spends a lot of their time is in the testing phase in there, so making sure the changes that we're making, the QA environment is still responding the same way, so that when a customer finally does cut over and go live with Akamai, it ultimately has no impact to the end user and that it was transparent. Now, ongoing, so once that initial integration's done, you might come back and do a few rounds of tweaking. What we found with several of our customers is you get that biggest bang in that initial integration, and then you're spending rounds of tuning to squeeze additional levels of optimization out of it. The customers that tend to be those big number one guys on Keynote and Gomez are the ones who have been doing multiple rounds of optimization for quite a while. So in terms of getting started, it's very easy. Expect less than about 30 days. In terms of getting to be the number one in your vertical, that probably is a longer process. I would probably say that's a year-long initiative to really move up there.
All right, great. Thanks very much, Rob. Lorenz, here's a pretty basic question, and that is Akamai a software or a control center? Exactly, what is the nature of the service that we provide?
Sure. I think the best way to think of Akamai is essentially an extension of your infrastructure. So in other words, it's a service, very easy to set up. You can control it through our control center through the browser. And once you're actually on our platform, you can leverage a number of different services by actually being on the platform, everything from what we call web experience or web acceleration, web performance, to obviously security, as we touched upon, as well as media delivery and other kind of components that we can make available. So it's definitely software, but you should really think of it as a cloud platform.
Okay, thanks very much. And then, Lorenz, another question for you. What are the one or two biggest things that we could do first to have the most impact on mobile performance?
So that's a little bit of a tough one. To be honest with you, I think some of the basic things when we think about performance is obviously speed, right? But then as we saw, speed is just as important as availability. So I would think focus on making sure that you get the availability component right first. Make sure that you have a scalable site that also performs well. Now, to start with, early on from a performance perspective, particularly if you're serving a global audience, right, one of the easiest and quickest ways to do this is to start to get content as close to your end users as possible. If you have a little bit, I would say, more resources, either internally or from a budgeting perspective, you can then also start to get more sophisticated. And as we saw, mobile networks usually have pretty high latency, right? So the more you can optimize your application to use as little of the network as possible, right, as well as send as little data over the wire as possible, the better your end user's experience will likely be.
All right, thanks very much. I think we have time for about one more question here. Just want to keep our event on time today. So if anybody's got that last minute question, go ahead and enter it now. We do have one. We do have another question here, which Lorenz talked about a little bit, but I'm sure he can talk about it some more. The question is, we also leverage a lot of third-party content on our mobile site, and how do we ensure it doesn't impact our customers if they have an issue?
Yeah, that's a tough one to answer in a minute or so, but it really depends on your application architecture, so to speak, and also how you're integrating with that third party. If you are doing it through JavaScript, for example, so in other words, you're making a JavaScript call for other content that you're loading dynamically into the page, one of the ways, depending on the functionality, that you can overcome that is to remove the actual blocking of that JavaScript, if that's what's currently happening. So in other words, other things can actually go on in the browser, even if that JavaScript call actually times out. The other thing is, if it's possible, you can actually even defer it until after the onload event, if it's not necessarily required for the initial rendering of the page. But the bottom line is, however you get to it, you just need to make sure that A, you test what your site actually will fail like if a third party goes down. There's various tools out there that allow you to do that. There's a great extension from the web page test founder, Pat Meenan, that you can Google that will actually allow you to have a very easy plugin in Chrome where you can actually figure out what happens if you have a SPOF moment, as he terms it, which is essentially a single point of failure in your site. So understanding what the risks are, I think, is the first step, and then once you understand the risk, is making sure that you essentially fail gracefully so that your end users won't be impacted if a third party actually goes down.
All right, thanks very much. That concludes our question and answer session. For more information related to today's webinar, please visit any of the resource links that are now open before you. Within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Additionally, you can view today's event on demand by visiting informationweek.com events/past. Excuse me. Thank you for attending today's webinar, brought to you by Akamai and Information Week Financial Services. This webinar is copyright 2014 by United Business Media. The presentation materials are owned by or copyrighted by Akamai. The individual speakers are solely responsible for their content and their opinions. Thank you very much for joining, and have a great day.